Greetings, everybody, and welcome to today's interest session. Interest is ETIC's remote engagement sessions in technology, a program we started a few years ago to introduce students to many technologies that are proprietary in nature, but that have an enormous amount of jobs that are out there and that have a career path. Some of them have a career path of their own. So we run things like Python and C# and Visual Studio and cybersecurity and things like that. So out of the 12 or 14 sessions this year that we're hosting, one of them, today's session, is in Java. In Java, we're going to give you the kind of the history of Java, the background of Java, why it's so important, why it's so popular, and what we can do with it, but also give you a hands-on demo of what it really means to become a Java developer. Now, some of you who come to these courses know some of these things already. Some of it's new. I kind of keep it very vanilla for everybody, so you get a good idea of the overall technology, and hopefully it helps you to kind of think through different career options that you may have and things you want to do, things you don't want to do, and that's kind of the whole idea of this program. All right. For those of you who don't know me, I'm Dr. Nizik. I direct something called our ETIC, our Entrepreneurship Technology Innovation Center, where we actually create programs like this to give to students through the program. We are a prototyping center that we create high technology prototypes for startups under contract, and our biggest contract is actually with NASA. We have government contracts as well, and New York Tech students like yourselves, come in as ETIC interns and ETIC engineers and project managers to do that work. So we are here at 107 in Harry Shearer Hall. And we are in room 607 at 1855 Broadway in the city. So there's two ETICs that we have. All right. So with that, let's continue with our kind of presentation here. And if you want to kind of take a look at some of the things we offer here, we have NYIT.edu/ETIC. You can take kind of screenshot of that and go visit the website. We offer our Ursula robotics project program that you can join that program and enhance our internal robotics program here called Ursula. We have a certificate program, a 25-hour certificate program here you can join and build new technology that becomes an asset for ETIC. You get a certificate signed by the dean and myself, plus you also get a merit page. You can also participate in any of our hackathons and competitions that we have. We compete in NYIT, we compete in the Port Authority Challenge. We have the IAC Squared Hackathon, the Cyber Hackathon that we run each spring, and also for those cybersecurity folks that are out there, the DoD CYSP scholarship program is starting November 1st. So you'll get an announcement from us sometime in November to come and start applying for that if you are in any of the cybersecurity designations, the concentrations. Okay. And that's kind of roughly what we do at ETIC. The other thing we like to put out there is that we also have a YouTube channel. So if you go to at NYIT ETIC, so if you go to YouTube /at NYIT ETIC, that is a YouTube channel. We have about 40,000 views now, about 57 videos, and we kind of release one video every week or two, different kind of shorts and things like that, different things you might be interested in. So go there and subscribe and take a look at what we have for you out of there. Okay, so let's talk about Java for a second. First and foremost, the reason we run this program at all is to introduce students to technologies that they may not have known about before, or at least not have known maybe at the exposure that those technologies are operational out there in industry. And additionally, we like to always treat this program, we like to always treat it as a career-focused program, where out of the 14 sessions that you may have the opportunity to go to, you come out with, hopefully 14, but let's just say you come out with 7 new paths that you didn't know exist before. That's a win-win for everybody, right? These are there to introduce you to things that you weren't sure that were a technology or how it worked, but you also understand out of these that there's a very direct and structured path to get to that, right? So Java, you hear it all the time, and your JavaScript and Java and so forth. But as a Java developer, right, you notice that the career path, this is about 4 years old. I mean, these are probably about 10%, maybe 15% higher now. and they're incredibly hard to find good developers that can actually jump right into projects and manage those projects. So if you get a few years of experience working on projects at New York Tech in any capacity, and you become not just a good developer, but you also become have a kind of a portfolio, technology portfolio to show the products you worked on, which is kind of what we do here at eTech for students. Those portfolio projects that usually kind of differentiate you from every other person that comes out of a computer science program or information technology program. So if you don't know, if you are on one of our programs here, we do use Java. We use a ton of Python in the eTech here in our projects, but in our courses, we use program 1 and 2 and discrete structures and data structures and so forth. We use Java just to give you one language that you become really good at, and then apply some of that knowledge to other languages as you learn them. Right, but if you look at, just some of the salary ranges here, for something called a senior Java developer, very, very lucrative, life-changing type salary from going from a student paying tuition into somebody entering the workforce. Really, it's the best word I can come up with is life-changing. That day that you go from being a student paying tuition and money flowing out to that day that you get this particular job, and within the first 2 weeks you've got checks coming in. It really is. It's the best thing the best way I can explain it is a life-changing moment that you'll remember forever. And that 4 years that you put in really just changes your life, where now you're on a completely different track. So it's all so worth it. With that, thinking about this, the other thing, just let me hit real quick. So you see senior Java developer, just so you're aware, senior doesn't mean senior age-wise. Senior doesn't mean 20 years experience. Senior means 3 to 5 years. So as soon as you build up 2 years of experience, 1 year in college, 1 year at an internship, and then the third year, possibly your first job as a programmer, you're starting to approach that senior, you're starting to approach being able to be qualified for that, these senior positions. And once you get to the 5 years of actually building applications in some capacity, you really do start to fall right into these types of jobs. So it's a very quick path, I should say, to become a career-based developer. Okay, so we have languages, right? So whenever you talk about a computer and a processor and memory, and you talk about some sort of high-level code that's logical, that we look at as human beings, and we automatically logically create our classes, methods, and our functions and things like that. But the computer doesn't read it like that. Computer like binary. So it takes these languages and it compiles them into computer code, into binary, into what we actually call a binary. And then that computer runs that binary. And it does what it says. So it looks and feels like what you wrote in code, but when you write things in a language, that language ultimately winds up compiling it to do certain things at the machine level, right? So we have machine level code. That's what compiling does. So with Windows applications, you have an exe, an executable, something.exe. With Java, you have a .jar, Jar. But those are objects. Those are machine code, machine level executables that run at the machine level, right? And they run very quickly, very fast. And languages that you choose create that executable that they're designed to do, right? So if you look at the top programming languages, a lot of these are C family, we call it C family of languages, right? So we have C, right? We have C++, we have Java, JavaScript, and C#. I'm not going to include PHP currently for a certain reason, because it's not really, I don't really consider it to be in the family, but it's close. But one of the reasons we call them a family is because the syntax and the ability to include packages and libraries and things like that is all extremely similar. What does that mean for you career-wise? What it means is that I went to school and I studied Java, and I know how to do every single thing in Java. I can create new projects. I can create new packages. I can create classes. I can create conditionals and loops and variables, and I can import data from external sources. And I can attach to databases. Okay, but I can only do it in Java. Well, the C family of languages, based on what you've learned to do, everything that you do is available in another language. You just have to learn the syntax. The syntax to any C family language is extremely similar, right? The bracketing, the tabbing, the spacing, the identification, the semicolons, right? The syntax in making the system in all these other languages is very similar. So if you see a C job open, or you see a C++ job, you see a Java job, or a C# job. C# is Microsoft's version of C, and it works with the .NET Studio, .NET package. So that's actually, they're really easy to learn as long as you've learned one really, really well. If that makes sense, right? And if you look, the top programming languages being used, Java is one of the top. Python is extremely flexible and it keeps growing in ability, so it's becoming unbelievably powerful and well accepted. The issue with Python is it doesn't really compile where you can actually sell your software, right? You can sell your services, but you can't really sell your software. And when a company is a software company and they're making applications, they want to be able to take the proprietary application that they're creating the software in and the syntax, the actual code, but the object that it creates, the executable that it creates, that you can sell, right? So you can't really sell any of the other stuff that's proprietary in nature. But once you create that object code and it does something that somebody asks you to do and it's in demand, you can sell that executable, right? You don't really sell software anyway, you license it. You always own it as a company, but you license your software to somebody who wants to use it. So anyway, like when you buy iTunes, you're not buying iTunes, you're paying for a license to use it the way they tell you to use it. That's why you got to click all these user agreements and everything. The company, always, Apple always owns iTunes, the technology. All right, so so Python's right up there, right? So it means that it's going to be in all kinds of different job requirements that you may need to learn Python and something else or whatever it might be. On this slide, doesn't really have this, but I'm going to talk about it now, right? So there's something called, you'll see it around, it's called a full stack developer. And a full stack developer is somebody who can do multiple components of a full information system. So an information system, we always look at it as a 5-component framework. Now we're adding in the 6-component telecommunications, but it's always hardware, software, data, procedures, people, and now telecommunications for like internet and communications, right? So 6 components. The full stack developer looks at every portion of that, right? They look at, I'm really good at hardware and I'm really good at software and I can do database management systems and I can make my software attached to the database that runs on the hardware and then I could train the people, right? So when they say full stack developer, they want somebody who could build the UI, user interface, somebody who could do the code behind the user interface, somebody who could actually create the database structure and attach the database. Like it's a really powerful position and well paid too. But it's something to strive to. It's something to set your goals to. It's not something to basically say, oh, I can't get a job as a developer until then. But just keep in mind that's what that word means when they're asking for that. Okay. And the other thing I like to bring up in these programming type lectures is that it's really important that you understand 1-tier, 2-tier, and 3-tier programming applications and developments, right? So what that means is that if you build a program like you do in your classes right now, like I teach data structure, so in that class we do a lot of programming every week in a project at the end. And what happens is when you write that program, it's doing something, but it's doing something inside your IDE and it's giving you the output, and it's not really doing anything outside of your laptop for educational purposes, right? That's a 1-tier application. Right? It's plenty of 1-tier applications. A phone app is technically a 1-tier application. Every single portion of that, the application layer, the data layer, and the presentation layer are all on the same platform, the phone. It might get an update from the internet or something like that, but really everything's on the phone. The 2-tier architecture is different. It's a client-server application, we say. So the application, the coding, the user interface is on the computer, on the phone, on the tablet, but it's reaching across a network or an intranet or even the internet, and it's attaching to data that resides somewhere else. Right? That's client-server. So it's reaching across the internet and kind of across the network and getting data from a certain machine that it's sitting on and pulling it down and processing it locally. The benefit of that is that the local machine, if it's really fast, it'll process that data really fast. The downfall to that is that it's got to pull data from possibly very far across your organization, physically far, and then pull it down, which may slow down some of the processing. Okay. 3-tier architecture is when your application layer, your presentation layer, your data layer all reside on the same platform. This is called cloud computing. So when you design a piece of software that all you need is some sort of program that runs your software, we'll call it a browser. But basically, like if you use a browser on any of your devices, which all devices have them, and that browser can run the software, then that software is really running on a server. The benefits of this is that there's one place to make bug fixes, enhancements, and everything else. One place, and 11 billion users, or how many users are on the internet now, can get that at the same time without any updates to local machines. Big benefit there. The other benefit is that is the speed. So since you're not going across the network and you're not dealing with internet, network slowness or workstation traffic and stuff like that, everything is working directly on the server. So it's lightning fast. Like the actual coding attaching to the database and the processing is all happening on the server, except there's no delay between the communication. So it's unbelievably performance-wise, it's incredible. The downfall is every time a user connects, it's called a session. And the session, the server that's running that one session is running a real version of the software. So if you have 1,000 sessions, 1,000 people connected on the software, that server's got to run 1,000 sessions. It's got to be an unbelievably powerful machine. And that generally is very expensive to install and maintain. So you have positives and negatives with each one. My big long-winded explanation is that Java and JavaScript allow you to do all this. Tier 1, 2, and 3 applications, Java and JavaScript will allow you to operate at these levels, right? So if you build a web page, an HTML page, it's going to basically display pictures and images. Your JavaScript behind that page will allow you to do any kind of interactivity with databases and stuff to generate them. Okay. Okay. So anyway, so that's all. Just another client server piece. That's all. Just the introduction of interest, of ETIC, of Java, and everything else, and where it lies. And now let's see kind of what it looks like. Okay. So we'll be using our training server to demo some of this stuff. And one thing I want to point out to you is a couple of things. Right? First of all, there's no cost for any of this stuff as far as getting it to run on your machine. The first thing I wanted to point out is that there is a Java website, and you download Java. Now, Java is not a program that you use. Java is an underlying system that will run on your machine, right? Once your machine has Java on it, it can run all these Java applications, right? So if somebody creates a really beautiful Java application that solves world hunger and basically, allows for amazing changes and betterment for you, great, but you still need Java running on your machine to run it, right? So the application is the application, but it requires a Java framework to run. It's called a JVM, Java Virtual Machine, and when that runs on your system, almost every Windows machine comes with a standard. Almost every Mac does. Almost every Linux box comes with it. But you do periodically see an update happening. But just in case you don't have it or want to install it from scratch or want to use it, you go to the Java website, you download for your particular system, whatever that is, you download that version. Now, why is that important? It's important because Java is system agnostic. It means that it doesn't care what system it's on. When you write your code, you will never write that code again. And there's a little bit of a right as far as the iPhone apps, right? There's a little bit of a tweak in there, but overall, only iPhones. But overall, if you write your program and you create your program, every single Linux box in the world, every Windows box in the world, every Apple OS in the world, every system in the world will be able to run that system without you making special versions of that. Now, that's not like anything else. If you make a Windows application, it'll run on Windows machines, but it won't run on Android. It won't run on Linux machines. It won't run on Unix machines. It won't run on Mac machines. So you've got to create that application every time. So if there's a really popular application and you create it, you've got to create it for Windows, for Mac, whatever, if you use something other than a system agnostic language. So Java is incredibly valuable and popular for that reason, right? So that you have this one-time version that you create with that becomes a standardized, but where once it works, you don't really have to do anything. Well, that's not, you don't have to do anything again, but you don't have to recreate it for every operating system. So that system standardization and agnostic feature is unbelievably powerful. Right now, once Java is installed in your machine and the JVM is installed in your machine, there's also something called a JDK, the Java Development Kit. When you want to run a Java application, you just need Java, the virtual machine, which is just a regular Java update or install. But when you want to develop applications, you need the Java JDK, the Java Development Kit. So I don't have a download for that up here. But let's bring that up so you can see that. I believe, yeah. So the Java Development Kit is what you would download for your particular machine, right? So anytime you want to build an application, you need the Java Development Kit too. Now, thirdly, there's tools that will help you build called IDEs, Integrated Development Environments. You're going to see one today called NetBeans. And those tools allow you to create from your idea, from your napkin sketch, from your whiteboard sketch, create the application visually and then test it all in one application. Those IDEs are not Java. They're the IDE that uses Java to show you, but it organizes your code in a way that you can think straight and get your mind through it. Now, if you look at let's just see, I just 10 best Java IDEs here. Just a quick list I found. Right, Eclipse, we're going to use NetBeans today, but Eclipse, IntelliJ, BlueJ, JDeveloper, JCreator, Dr. Java, Xcode, Greenfoot, and MyEclipse. These are the ones I used to use Eclipse. It got a little too big complex for what I needed it for teaching and some other stuff we do. So I just use NetBeans now. I like it a lot. A lot of students use IntelliJ. They're like fanatical about IntelliJ. And I've seen a lot of students use BlueJ. So, you know, kind of out of those IDEs, when you download those and run them, that IDE will attach to the Java JDK, which will attach to Java, and it'll let you build applications. Right now, when you build an application, you create what's called a jar.jar. That's the executable. If you take a JAR file out of a program you created and you send it to any other computer in the world, meaning any other computer, because they all run Java, that program will run the same way on every other computer once you create that jar. Okay, and that's the value of that standardization. Now, the one thing I wanted to point out here before we get into anything on the demo side, so many of you are into data science and machine learning and stuff like that. And I wanted to just bring this up kind of beforehand, is that these are kind of some ads up here. So there's libraries that Java has that are machine learning libraries, right, that exist. So we're all used to some degree Python, and Python's got an amazing, you know, kind of scikit-learn and stuff like that for Matplotlib and scikit-learn and data visualization and stuff like that, and that's great. But Java, just to prepare you, if you're thinking one or the other or both or whatever, Java has all these different library existing, and they always get updated and they always get included and always get downloaded basically when you need them, right? So keep that in mind as you also move into this world of machine learning and deep learning and machine learning. They have all these available for you as well. Okay, and with that, what I'll do is I'll jump over to our training machine. And the machine I have, the system I have up right now, you'll see if I click here, it's just a Windows server, but essentially runs just like a Windows machine. So what would happen is that you would basically install your IDE, and you would just double click on the icon. And once you do that, you're into the actual system that I'm in. So everything I do now is going to be, based on you installing your IDE and running. So what's the first thing we see? It's just file, edit, view, navigate, everything else like a regular program. The difference is when we go to file and we create a new project, those projects come up as all different types of Java projects based on what you're trying to do, right? So what you're trying to create is dependent on what you're trying to do, right? So if we just select basic Java and we go into Java application, that's going to allow us to create like a desktop application that we learn, that we use for all kinds of things. Just so you're aware, like desktop applications, as far as we call them console, in C# we call them console apps in Windows, but like anytime you want to run something behind the scenes that will do something to your operating system or to your files, that's always a console app. So I'm just going to clean my glasses. I have something floating on the side. That'll have to get edited out. So anything that you have that needs to run on a machine to automate something, system automation, whatever, always console apps. You always need these local applications, right? And Java FX, Java Web, right? Anytime you're building a web application with Java, you have the ability to do that. Java E, HTML5. HTML5 is the latest version of HTML. It's kind of like got an active script component like like ASP.NET and Microsoft Visual Studio. Really, and just tons of other, applications that you could use. But overall, Java and Java Web are two of the things, and HTML5 are really three of the things that you use quite a lot when you go get a job and somebody says, okay, we need for this new customer, they want this. We don't want to touch our existing system, so you have to build a new application that does this and interacts with stuff. Really, that's a big part of work is your salespeople go out and get contracts, and they come back and say, here, do it, because they're going to pay us if we do it, and it's your job to figure out how to do it. That's really what the world is like. Okay, so once we create those projects, they wind up being kind of over in this project section over here. One, I'm going to start with something called this method demo I use. I'm not sure if any of you have had me as a professor yet, but basically we do this simple exercise to just refresh everybody on certain things with Java, on how to do certain things. But this is a real good idea to explain different pieces of Java. So in Java and in an IDE that demonstrates Java, we wind up looking at the project name, but then underneath there's something called source packages. Packages are important, right? Packages allow us to, inside of a single project, create all kinds of classes that can be of the same name as another package, but because they're in a separate package, we can reference them. So when we reference a package.class.method, we can be more powerful and we can standardize. We can create a package called external data control. And that package, all that package does is control classes that are outside, dealing with outside data, right? Then we create a package called internal data control. Then we create a package called module standardization or whatever it is. And inside those packages, we can have all kinds of files that need to get duplicated because they do some other standard stuff, but you don't want to go renaming them, right? I don't want to rename my class names just to keep them separate, right? I might have 500 classes that I use over and over and over that do certain things, everything from changing font sizes to centering to doing all kinds of stuff. Those classes I use all the time. Well, if I need those classes in one package or the other, I can include those as the same name. So this package name, class name, method name is the way you reference them from one class to another. So whenever you see a package in Java, that's really what it's referring to, right? Then you'll start to see different Java classes inside of a package, and then you'll start to see only one will have a green arrow on it. Every different time you have a package, one of the classes has to be the main class that the project reads to start up, right? It needs to go somewhere to start up. And what it really means is that that particular class has a main method, right? So even though this class is called main, the reason that there's a green arrow is because there's a main method in it. So the main method is what Java looks at to start a program. It's the first place to start. Okay, so let's open up this main.java, this class. And you notice the first thing that has to happen in Java is we have to actually declare the package that we're using. Otherwise, this class doesn't really know what package it belongs to, so it doesn't know what else it can reference in that package, right? Once you declare the package, you can just call classes by name, and then it assumes it's looking for that class name in that package. All right. Then you have the regular, normal C family of language declarations. Okay. We have and syntax, right? We call a class public or private, basically. We want people to see it from other classes. We have a main. We have the name. We have the main name here, but this could be any name for it. We open with brackets. We make comments with slashes. If we have more comments than a single slash, we make comments by slash star, and then all of our comments in star slash. That way we don't have to put slashes in front of everything. We have methods that are static in nature that don't require any kind of feedback as declared by void, designated by void. And then on this internal method, this is the name of the method. Open parentheses just means that it's not expecting anything into it. It'll just run, right? It's not expecting kind of data to be sent into the method. And all it's going to do is going to output on the screen this particular series of lines, right? Then you have your main method, and in the main method you have every single thing that you want this program to start with before you before it loads up anything else, the main method is where it starts. The main method tells it where to go. So your main method usually contains all the different kind of menu systems and anything else you want, but everything else that those menu systems do winds up getting called by another class, right? So to run anything in Java that is a single method, we simply just inside of whatever method we're using, in this case the main method, we just call that method by the name. So if that internal method, open paren, close paren, is the name of that method, we just call it with a semicolon. It's going to run that method, whatever it tells it to do, right? If we have a method that's located in another class for organizational purposes and hierarchical purposes, you don't create everything in one big class. It's called spaghetti code. You'll lose your mind trying to figure out what's happening with that. So what you do is you create another class. In this case, this class is called external class, which is located over here as a separate file. Okay. And then this external method is located in that external class. Now, we don't know what external method will do. So what you do is you open the external class. I think it's going to, sorry, open the external class and then read what it does. And what it's doing is it's saying, okay, inside the external class, there's an external class, there's an external method, and that method says to output, this is how you call an external method, right? So all these different ways to interact with other classes allow you to organize your code in a certain way so that as you're operating, you don't have one big giant class where you're trying to read through, when a problem happens, you have to go fix it. So you want to know that somebody have a problem with the tax calculation for New Jersey. You know that you can open up the class called tax calc and you can go to the method called New Jersey tax calculation or whatever it might be. And you can say, fine, that's probably where the error is. But if all of a sudden it's in one big class and you've got 5,000 or 20,000 lines of code in there, it's very, very difficult, sometimes impossible to weed out what's happening. Okay, and then so when we run this, just to give you an idea what happens, we run in the IDE in NetBeans in this case. It is running the code, and if you notice a web page came up, one of the things that are in here is an example of how to interact between Java and the web. So what happens is each one of these outputs, right? This is how to call a method. This came from the internal method. So this is how to call an external method. This was printed from this particular line right here. Compound interest is 16,288. That was created from this particular class and method, right? In the calculate interest class, there's a method called interest calc. And notice whenever we do math in mathematical functions in Java, we have to which winds up making it faster, believe it or not. It doesn't have to do any of the work by declaring what the type of variable, integer, double, float, whatever it might be, and then converting those variables into text or numeric values when needed. It's actually a lot faster because you're doing that ahead of time rather than having a high level language being like add this and this, like a Python. It has to break those down into the types first and then do it. So it winds up being slower. All right. And again, so whenever you're declaring variables in Java, it's just the type of variable plus the variable name. If we were going to declare a string variable, we would just do string test123. And then that would be the string variable, right? I think it's lowercase, so I'm kind of screwing that up with that. But essentially, we can have declaring variables and whatever that name is and setting them equal to something else, doing that dynamic. All right, so we have, it's a numeric value with a double format, and then the name of the variable is test, and then whatever the value is that number, right? So now, and then whenever we're dealing with mathematical components or features, we're basically taking some sort of function that already exists, called information hiding, it's called abstraction, some sort of function that that Java makes available, right? Exponents or sine, cosine, tangent, right? Any kind of geometry, anything that's out there. All those functions that are in Java come usually from the math program, from the math package. So math.anything is how you would activate one of those features. You just do math.anything and feed it the numbers that are required for that calculation. And Java does a really good job and really expedient job of processing that that functionality. So anyway, so the only thing that I like to cover in this particular portion, no matter whenever I do this, is that one of the things that escapes students when they're developing a lot of times early on is that you don't have to create everything in a single class, but when you do create things in separate classes, there's always a little bit of a loss or a gap between how those classes talk to each other and how they exchange data between them. So whenever we have objects, object-oriented programming, objects have names, behaviors, and attributes, right? Once an object exists, it can talk to any other object, right? And what that means is that with classes, we can basically say, look, this class exists, this class exists. We're going to basically process something in this class and then send that value to this class. And whatever that class uses that value for to create a new value, it'll send it back to the other class, right? So we have this way to really organize our code in ways so that there's very, very few lines of code, but that's very powerful because it keeps feeding off of each other to produce some sort of complex, complex process. And the way we do that is with a simple explanation. But if we do this return method as an example, right? Well, let me do parameter method first. The parameter method here that we use here, what you'll see in the parameter method is that when you create a method inside of a class, and that method is designed to receive a certain amount of external values, every time you call that method from in that class from any other class and any other method, you have to give it those values, even if they're null in nature. That you still have to give them those values because it's looking for those values, right? So when you call that method in that class and you send it whatever it's looking for, it's going to read those in and it's going to process them. And then whatever the result is, you have the ability to read that back out. Okay. So how to do that is essentially what this is doing here. In this case, the parameter method class, right, has in it a parameter calc method that is saying, look, when I'm going to be run and I'm going to do my job, somebody has to give me 1 integer, 2 integers, 3 integers, and a string value, right? Whether that's 3 house numbers and a street name, or whether that's 3 statistic values and a statistic title, or whatever the reason that is. That method requires those values to do what it needs to do. And in this case, when we call parameter calc from some other program, it's reading in whatever values we give it, and then it's saying, okay, we're going to set up a variable called total. That's a type of double. And then we're going to add in A, B, and C, which have already been set as variable names in the import. Okay. And then what happens is you're able to set those variables in some other type of program. In this case, we're calling a website. It's one of our Ursula robotics programs. We're calling that website, and we're actually replacing those values with motor controls for that. And so what happens is that when you call that particular, as an example, if I go to the main class, right? If I go back to the main class and you look at, right, the parameter calc method, we're sending through 1 integer, 2 integer, 3 integer, and some text. So we're calling that method with values, and then that method is designed to read in those values and do something with them, right? Now, the last piece of the puzzle with Java specifically is that you need to be able to do something inside of that. You need to be able to do something inside of that method, but then whatever you come up with, the secret sauce, the final answer, the thing that the problem that you've been working on solving, whatever that answer is, you need to be able to send that back to the calling program. And the way we do that is with the word return, right? So in this particular example, if we do return amount, it's looking for an integer, two integers and two double values, and then it's adding them together. But that's what it does here. But look at the difference. The difference is that once this variable is set, we now return that variable to whoever called it, right? That's what we do, is we return that variable. Now, if you look at the main, see if we go back to the main job. Okay, if you look at this right here, it's so simple. It's so simple. We're basically setting up what type of variable this is. We're naming it return variable, and then we're setting it equal to the method and the name plus the values that we want to send it, right? Which means that return variable in your calling class becomes the result of whatever complex software programming you did in this other class. Simply because whatever it does, it rips through 5,000 iterations of some sort of a algorithm you created and comes up with an answer. The answer gets returned because we called it in this way, right? So if your amazing software creates some sort of a program, an answer that never was created before, which I like people to think, you think about that, how do you do something really unique? When you call that method and give it the right data that it needs to work with, it does its job, but then whatever the answer is, it gives it back to the calling method. And then you're able to do anything you want with it. Display it, show it, print it, save it, write it out to a text file, email it, whatever else you want to do with it, all right? And that's the cool thing about hierarchical programming, object-oriented programming, is creating these projects and these packages and then these separate classes, and it becomes really structured and organized, and each class is named really, really specifically, so it's easy to fix, easy to maintain, easy to upgrade. And then also inside of them, each one is kind of collecting the minimal amount of information that it needs and only what it needs, and then sending it out to the other module, which is doing only what it's supposed to do, right? It's a really streamlined, efficient way of working. And I always like people to see that in these introductory sessions, but I also like people that are programming already to kind of remember that that's what you're really striving for. Okay. The other thing I want to make sure I cover for you is something called data structures. So anytime that we're working with Java, really any language, but there's something called classic data structures. And those classic data structures are both linear and linear and tree-based. So in linear models, we have arrays, array lists, stacks, queues, linked lists. And in tree views, we have binary search trees and not hash tables, but we have priority queues and heaps, we call them. Those are tree structures that basically cut the work that you have to do in half, right? Linear structures, the bigger the data gets, the bigger the task. We call it O notation. It's the more data, the more time it's going to take. With tree structures, they're more complex to create and manage, but they always cut the work in half whenever you're searching, right? So you have two data structures that you need to understand how they work in Java. And what I'll do for that is the first thing I'll do is I'll do some basic, something fairly basic. We'll see if we can get a stack. So a stack is a certain type of structure, and that structure is last in, first out. You're taking data as it comes in, and the stack only allows you to look at the very top item. You can look at it and leave it, or you can remove it, or you can add on top of it, but it doesn't let you do anything else with the other data. Anytime you deal with peripheral type of data, input from a keyboard, from a mouse, from a camera, anytime you have streaming data coming in, it's almost always a stack that we use to bring it in until the processor has time to process it and then read it back out, right? It's like a temporary holding facility. So stacks are, you've heard of Stack Overflow, right? That's what it is. Stack underflow and overflow is when your stack kind of isn't designed properly and you overloaded it. But just to give you an example of how these data structures work, because they're not native or automatically included in every program project in Java, you have to import in a particular package that uses it for it. In this case, we bring in import java.util.stack. Once we do that, we instantiate the object, right? So we instantiate the object where we give it a name. Then we tell it how it's going to behave. We tell the system objects have names, behaviors, and attributes. We tell the system that CSC260ST, that object name, we tell it that it's a stack and it's going to behave a certain way, right? When we put data into it, it's going to build it up. You're not going to let any user look below it. There's no need to do that, right? And we tell it how it's going to behave. And then we have transformers. So these are constructors, and these are transformers. When we push and when we pop, when we push is adding and popping is removing for the stack. When we push and pop, we're transforming the transformers, right? Observers are when we look at it, we usually call it peak. It's not in this one. And what happens is when we run this, we see what's happening. It's actually creating a stack, and then it's adding all these variables to it. Now, when you take a data structure in Java and you instantiate it, that data structure is out there in memory now. You've altered the computer's memory to temporarily hold this information out there. So whether you have 600,000 entries from a text file from some weather data that you collected, or a billion names from some other, or stock values or whatever it is, you're probably used to building applications now, if at all, but you're probably used to building applications where you're running the program, it's doing something, and it's all in one program. You may or may not have actually created objects that you take a ton of data that you've created or yourself, or you're bringing in from an outside source, and temporarily stored it so that as you jump around through your classes and your program's running, that data always stays available for you in that object, right? That's the beauty of data structures, is that those data structures get created, but they don't break down when you close the class. When you go to another class, they're still open, right? You can still access them. So this is a stack, and we've added all this information to the stack. If we change one of them to to another campus, campus 1, whatever it might be, you'll see that stack gets recreated and then has the new information, right? The new information in the stack, right? So we're transforming with new data. Now this data can be collected from a user, from a scanner class or something like that, or from outside sources, right? The other thing that we can do is we can take those data structures and we can sort them. One of our algorithms that we use is called a bubble sort. In a bubble sort, we wind up bubbling up the highest value of, in this case, the array that we're dealing with is full of all these different numbers. And we almost always, at some point in computer science, we want to basically take whatever data we're working with and sort it, organize it, right? High to low to high, whatever it might be. And there's algorithms that do that, right? One is called a bubble sort, where we bubble up the highest number to the end, and then we basically do a pairwise comparison of the first two numbers, the second and third number, the third and fourth number, the fifth and sixth number, and so forth. And we keep comparing them to each other until we get an ordered stack, and we reverse them if so. And what you'll see here is that we're basically creating the array that's of numbers that we need to sort. And then we're basically looking at each of the first and second numbers, third and fourth, and so forth, and we are swapping them. We're swapping, if one is greater than the other, we're swapping them, and we're doing that n-1 times. So if there's 100 items in the array, we're going to move the highest number up to the end, and then we're going to do this algorithm n-1 times, right? So we're going to do this 99 times. And what happens is that when you run this, it'll take this unordered array right here, and it'll place it in order, right? So you'll see the actual way it does that, right? So it goes low to high. So in Java, really in any language, you always have data structures. This is how you do it in Java. On the same note, you also need algorithms to manipulate that data. And with certain algorithms, we have sorting algorithms. The other thing that I will end up doing for you is we have something called a tree view, a tree structure, data structure, and that is a binary search tree. And what we do with that is we use the BT feature in the binary tree feature in Java, and we create left and right nodes of a tree with a root in the middle. And that root is like, if you have data and it goes from 1 to 1,000,000, your root is like 500,000, because you're going to have both sides of the tree average amount of data, hopefully, and you have something called a balanced tree. And when you have a tree and you have all the left side of the tree is less than or equal to the root, and all the right side of the tree is greater than the root, if that root is 500,000, if somebody asks you, is 700,000 in the tree, it automatically gets rid of half the tree. So you've halved your problem already. Then it says, is it greater than or less than 350,000? And it gets rid of the other half of the tree. So very quickly, you can find out answers to questions with binary tree. And to show you how that works, basically, once the left and right tree sides of the tree are created and the root is created in your structure, this is part of creating your structure. You're then populating that tree with data, and you're populating it on the left side or the right side based on its comparison to the root. So if you read data in and that data is 200,000 and your root is 500,000, you're going to put it on the right side of your tree. Excuse me, looking at the tree this way, I'm behind the tree looking at the tree. The left side is less than or equal to. And if it was, 700,000, it's going to go to the right side of the tree. So in your algorithm, as you read data in, you're populating the tree left and right for left side and right side for the values. Okay, so you have tons of data structures and algorithms in Java to make your program come to reality. And with that, we're running out of time, but I am going to stop the recording, open up for any questions, and then thank you all for coming. I hope you were enlightened to Java, to career paths, to a good visual of how it works and what you can do with it, and all the other components I showed you that are out there for Java. That this core coding, once you learn it, you can just import those other libraries for machine learning and things like that, and they just code around it. Okay, so with that, I wish you luck. Have a great day, and thank you for joining.